Hello everyone, it's Ms. Cyran again, and we have reached the third and final screencast in our transformation series. Let's review the goals one last time. Students will be able to identify and describe the three basic rigid transformations. We did that in the first two screencasts. In the second screencast, we took translations a step further and were able to use both vector and coordinate notation to describe them. This third and final screencast will allow you to identify and describe glide reflections, dilations, as well as frise patterns, and will also get you started on your tessellation project. What is a glide reflection? Well, a glide reflection is a composition or a combination of a translation and a reflection. So if we take a look at this picture here, triangle JKL is translated to the right along vector V, and then it is reflected over line L, giving us our new image of K prime, J prime, L prime. Now, frise patterns. They are simply border patterns, and they are horizontal patterns created by translations. If you look at our first example here with the music notes, we simply took one music note and translated multiple times. The same thing with our next image. Again, it was just slid over or translated multiple times. Now, with the arrow pattern, something a little different happens. We not only slide the arrow over, but we also rotate it 90 degrees so that it now is pointing upward. For the next image, we again translate it over to the right and rotate it 90 degrees now. So now the arrow is pointing to the right. That pattern continues throughout the rest of that frise pattern. We can go to the Illuminations website to experiment with these patterns. I would strongly suggest you take a little time going back to my original PowerPoint to explore these different patterns. Now, the first one is a translation. We can make the distance between each figure greater, and we can also distort the figures into different shapes. The next one represents a horizontal reflection. Then we have a vertical reflection. We have a horizontal and vertical reflection happening at the same time. We have a 180-degree rotation. A glide reflection, which we just discussed. Notice it slides and then it reflects. And then the next one slides and reflects. We also have glide reflections with rotations. Again, take a little time to play around with this website and just get a little bit of a better feel of frise patterns. Now we're going to move into dilations. Dilations are very different than anything we've talked about so far. A dilation is a non-rigid transformation in which the preimage is resized. Dilations are not isometries. And the reason a dilation is not an isometry is that it does not preserve length. Dilations can either be reductions, where you start with a large figure and make it smaller, or enlargements, where you start with a small figure and make it larger. We're going to check out a cool activity at mathisfun.com on resizing. This website provides you with some basic information on dilations, as well as this really neat interactive game in which you can make enlargements and reductions yourself. If we start with the preset numbers here of 1.5, our new image will be 1.5 times as big as the starting one. So if we start here, your directions are over here on your left. We have the numbers picked. We simply click resize. It gives us the original triangle and then makes a new one 1.5 times bigger. Now if we want to make a reduction, we simply change that number to something smaller than 1, click resize, and now our triangle will be made smaller. If you want to play around with resize points, that will change the center point of your triangle. Finally, let's discuss our tessellation project. Well, first and foremost, we need to know what a tessellation is. A tessellation, or a tiling, is simply a collection of tiles that fill a plane with no gaps or overlaps. This is very important. So what are you going to do to create your own tessellation? I strongly suggest that you turn to page 452 of your textbook and possibly the internet for help with this project. Page 452 gives you step-by-step directions on how to create your own basic tessellation. But please make sure you refer to the grading rubrics because you will get more points if you are more creative. After you're done your tessellation, you also need to write a 1 to 2 page report on how you completed your tessellation. Again, refer to the rubrics as to what you will be graded on. Remember, tessellations have no gaps and no overlaps. The first rubric you will see is your tessellation rubric itself, what you're going to be graded on the tessellation project. I will be looking at the definition. Do you have no gaps and overlaps? What shapes did you use? Were you a little more unique and creative? Your minimum size must be 10 inches by 14 inches. Did you use creative color choices to enhance your design? And finally, were you neat in creating your tessellation? The tessellation itself will be worth a total of 25 points. Next, we move to the report rubric. Again, 5 categories, 5 points each for a total of 25 points. Your introduction must have an accurate definition of a tessellation. You also want to include any mathematics that you use to create your tessellation, and I am looking for accuracy here. The next category is color. Here I'm looking for you to identify and explain your color choices in depth. The next category is shapes. I want you to identify and explain your shape choices, again, in depth. And the final category is grammar. I want your response to contain at least 1 page, that it's written in complete sentences, and correct grammar is used. After completing your project, you will have to fill out a self-evaluation. I would like you to read each of the 8 statements carefully, and you are going to circle how much you agree with that statement. A 5 would mean that you strongly agree with the statement, and a 1 would be that you strongly disagree. If you're somewhere in the middle, then you may circle the 2, 3, and 4. Finally, at the end, there are 2 questions I would like you to provide me with some responses on. And the very last part of your project is a peer evaluation. We are going to set up our classroom like an art gallery when everyone is finished, and you will need to turn in at least 5 peer evaluations. And if you notice, they are very similar to the self-evaluation. So what we have here is a summary of our whole unit. If you look at each of my topics here, there are links to take you back into the presentation as to where everything happened. And finally, at the bottom of the page here, there is a link to mathisfun.com. We use that in one of the activities that you can use for additional help if you're still struggling with transformations. I hope you found these screencasts helpful, and if you have any questions, please don't hesitate to ask me in class. Have a great day.